Now that you have narrowed down your most narrow particular kind of test from that master list, you need to figure out how many participants you would need to conduct that kind of test. It's going to be different for whichever different statistical test you have. And so to do that, you need to download the software GPower, and I'll give you a link to do that. And if you need help downloading and installing software, please let me know. This one should be pretty simple and small, but we could always hop onto a Zoom meeting and I can walk you through it if you share your screen with me. Pick your exact test from that previous table here, and then we'll plug in the information into GPower that it asks for, and I have tutorials just about doing that. But our first step in GPower is it's going to ask for our family of tests. So if you have a correlation or t-test, that's going to be in the t-test family. That's what you pick for the drop-down menu that looks like this when you click on it. And then more specifically after that, you would click on the specific statistical test, but I will show you that in a separate video. If your stat from that master list is going to be an ANOVA or an ANCOVA or multiple regression, you would click the F-test option in the test family drop-down menu. For chi-square, it's its own family and the only one we have in that category, and it will be the chi-square test drop-down menu. Hey folks, I just want to give you a quick tutorial on how to use GPower based on which statistical test you use, which is going to be kind of individual for you based on your data. So I'm going to share my screen and get us started. Okay, so this is what GPower is going to look like. I'm using a Mac. It might look slightly different on your PC, but it's going to have the same menu options. So what you want to start with is test family, and you'll select t-test if you're using an independent groups t-test, a dependent groups t-test, or a correlation. So I'm going to start with those groups of tests and show you how to do those. For any test that you do, this part that says type of power analysis should always say a priori compute required sample size given alpha, power, and effect size. Meaning, GPower needs us to tell it what's the alpha level, which is that we compare our p-value to that alpha equals 0.05. Is p less than or greater than 0.05? We want to keep ours at 0.05. We want a highly powered test. Anything close to 1 is high power. And for effect size, we want something high as well, although that's going to look a little bit different based on which test you are using. But what GPower is saying here is, give me your alpha power that you want and effect size that you want to find, and I'll tell you how many participants you need to get that. That's what GPower will spit out for you. How many people would you need to recruit to find those statistical results? So let's get started with a t-test. Let's say I chose t-test family, and then I need to pick means, difference between two independent groups if I have a between groups set up. And this is what the input parameters are going to look like. Y'all are going to have one-tailed tests because you should have a one-tailed hypothesis, okay? For effect size D, Cohen's D, we want to leave it high at 0.8. We want our alpha to be 0.05, and this might have been like 0.5 before, so make sure to change it to 0.8 if it was. We want high power, meaning that we have our test is going to be like really sensitive, able to find an effect, and we need a lot of participants to do that. And just leave this part alone, this allocation ratio. And don't click determine out here. That does a whole other thing. So just if that happens, just close effect size drawer. And let's go down here to calculate instead. And then what we see is what we're going to be looking for is total sample size. That is where GPower will tell you to find the stuff you told me you want to find, you need to have at least 70 participants. So you would need 35 in one of your groups and 35 in the other. We need equal numbers of people in each group for an independent groups t-test. Now, independent groups t-test is what you use, again, if your groups are two different groups of subjects who are not related to each other in any way. But let's say that you have two groups you want to compare, but they're like matched. A particular participant is matched up with a particular participant in another group for some reason, then you would use a dependent samples t-test, or if you had a within subjects design instead of between subjects, where the same group of participants is being measured 2 times on the same test, that is where we would also use dependent groups t-test. So we're just going to select that here, difference between two dependent means or matched pairs. And our effect size, we still want a 0.8, very high. We want a 0.05, and we want that error probability or that power to be 0.95, and we're going to leave it at one-tailed and press calculate. And then you would need 19 participants for that type of test. Now let's imagine that still in this t-test family, you had a correlation instead, where your independent variable and your dependent variable are both continuous. They're not different groups with levels. They're just numbers of things that can take any value, like age, for example, is one of them. And then your dependent variable might be like a score on some depression measure that's not just depressed or not, it's like a bunch of different numbers. So then you would do means. And what we're going to test is difference from constant or one sample case. The reason we would do that is with a correlation, we are testing whether that correlation is significantly different from zero. We're just testing that mean by itself, not two means. So your correlation and the mean in that group, we're going to again put this at 0.8, 0.05, 0.95, and calculate, and you would need 19 participants to do that. Let's say instead that you have a multiple regression, an ANOVA, or an ANCOVA. Those are going to be in the F-test family, so that's what we're going to select there. We want, okay, there's a lot of different choices here, so this looks a little scary, right? So for let's try our multiple regression first, because that's going to be our simplest one. Let's look at linear multiple regression, fixed model, R-squared deviation from zero. This is the one you're going to pick if you already had a continuous independent variable and a continuous dependent variable. And so like a correlation, right? But then you had a covariate you wanted to add, and then it transforms into a multiple regression. So that's what we're going to pick here. Choose the a priori option, make sure that's selected. So a large effect size here is going to be 0.35. We want our error to be 0.05, and we want this to still be 9.5, and we only have two predictors. You have one independent variable and one covariate. So then when you press calculate, this is what you're going to find. You need 48 participants in order to find the results you're looking for, to test your hypothesis in the best way possible. Let's look at these other types of F-tests real quick. So let's say you have an ANOVA. There's a few different options for ANOVA here. The simplest one you need to pick if you have a between subject setup is this fixed effects omnibus one way. And again, that is when you have one categorical independent variable with more than two levels. And that's the only predictor you have, and your dependent variable is continuous. And we want our effect size to be large. For this F effect size, that's a 0.40. And then how many groups do you have? Let's say you only have 3 groups, 3 levels of your categories of your independent variable, and then press calculate. And you need 102 participants. That's realistic and pretty easy to achieve if you are recruiting from online, so don't let those big numbers scare you. Let's say that you had a different type of ANOVA though. Let's say you had within subjects where you have a single categorical independent variable, but it's the same participants being tested 3 times, or kind of like in our independent versus dependent t-test setup. Maybe you have 3 separate groups of participants, but they're all linked in some way. Like participant 1 is like the exact same age and race as participant 1 in group 2 and participant 1 in group 3, and they're kind of attached somehow. But this is going to be, so if you have to match or balance across groups for any reason, using some kind of pretest, then this is what you would pick. I don't think most of y'all are going to be doing that, but I'm going to show you this one just in case. You would pick the ANOVA repeated measures within factors. Number of groups is how many groups of participants we had. So let's just say we had 1, but let's say we measured them 3 times. And let's say we want a high effect size. 0.05 is what we're sticking with for alpha. We're sticking with 0.95 for our 1 minus beta or power. And let's just leave all of the rest of the correlation among repeated measures and non-sphericity correction, ADA, let's leave those as the default and then press calculate. And that tells us we only need 18 people to find the effect that we're looking for. Remember, that's one of the advantages of a within subject design is that we don't have to go out and recruit multiple groups of people because our single group kind of serves as their own control group in a way, like their own comparison group at different points in time. Let's say instead that you had an ANCOVA. This one's going to be easy because there's only one ANCOVA choice here. But we have to put in some similar stuff as we did with some of those ANOVAs. So let's say 0.40 for the effect size F. You need to keep these at the defaults of 0.05 and 0.95 respectively. You should only have one covariate. Let's say for your number of groups, you should really only have 3 levels of your categorical independent variable, or like 3 separate groups of participants that you're comparing. And this numerator degrees of freedom is going to be however many levels of our independent variable we have. So that's how many groups of participants minus 1. So here we're just going to put in 2 if we had 3 groups of participants. And then we're going to leave number of covariates at 1, and we will calculate, and we need 100 participants. Again, that's not really a scary number. That's pretty easy to get in a few weeks' time when you're recruiting online, depending on the forum. So I think those cover all the tests y'all should be doing, but if you have any questions about which option you should pick in GPower, please let me know.